A piece of cheese is located at 12, 10 in the coordinate plane. So the x is 12, y is 10, so it's here. Okay. A mouse is at 4, negative 2. I mean, these days even mouse use Cartesian plane, eh? Okay, so here's cheese. And here's the mouse. And it's running up the line as y equals 5, negative 5x plus 18. So I missed it. So it's 3 more. It's there. And that's the line it's running through. So I always presume, if it's running on the line, it must go through that line. So here I assume it's going something like this. Now let's see if I get it right. Almost, but not quite. But let's live with that. We are not reading off the graph, so let's just get some ideas here. Okay, at point AB, the mouse starts getting further from the cheese rather than getting close to it. In other words, it's going to run along here, and this is an exercise in futility. It's running along. I mean, it's doomed. It's not leading to the cheese. It's just passing by it. But you can find some comfort in being closest to the cheese, maybe here. So that's the AB point where, smell was getting stronger, but now it's kind of fading away. I'm still hungry. What do I do? That type of situation here. So where's that is the question. Well, there are 2 ways to do this. One is you can think of getting the perpendicular line. That is, it'll be closest when these things are perpendicular to each other. Don't you think? So we know the coordinate of this, right? And you do not know the coordinate of this, but whatever this is, when you make the, let's put down the coordinate of cheese. What was it? Cheese is at 12, 10. If you find the slope with 12, 10 and AB, you will get a perpendicular slope to this, which should be positive 1/5. So that's one way of doing it. So shall we do that? Oh, why not? Let's do it. So let's find the slope of this thing. Rise over run. Rise is 10 minus B. Run is 12 minus A. Then rise over run will give you what? Perpendicular to this. So it's positive 1/5. That's what I get. Okay. So what is this then? Oh, you don't know. You got to compute this. I got 50 minus 5B is equal to 12 minus A. But thing is, this doesn't look promising. I need to know one more variable I need to have one more equation to find what A and B are. And here it is. If I plug in A, I should get B, right? So if I plug in A there, I should get B. So what's the equation then? B is equal to negative 5A plus 18. That's what it is. So now if I plug in B into here, shall we substitute? 50 minus 5 times, instead of B, I will say whatever is equal to B, which is negative 5A plus 18. That doesn't look negative, so let me doctor it to make it little. Okay, there we go. Is equal to 12 minus A. So now, if I multiply it all, and what do I get? Let's see, so 50 minus, will be plus 25A, and minus 90 is equal to 12 minus A. Okay, now if I move this guy to over here, is 26A, right? I'm adding A on both sides. And this subtraction resulted in negative 40. So I should add 40 on both sides. That would give me 52. That neatly makes A to be 2, which is kind of in tune with what I see. Huh? Okay, if A is 2, then what is B? Well, you can plug into either one. Which one should we plug into? I think this is kind of custom designed to give you what Y is or what B is. So I'll plug in here. If I put 2 here, negative 10 plus 8 is, and plus 18 is 8. It fits the picture that I see. Actually, what I see is a little higher. Is 8 here. So that's what it is. So A is 2 and the B is 8. So what do they want to know? A plus B, that is 10. Okay, this was a little involved, but it works, But however, any other way of doing it, you can actually find the distance formula for this line. And the distance formula will always be a quadratic. So now, suppose you're on a particular point here. What would that point be? It's going to be x, comma, what? You can say y, but that's too vague. It would be minus 5x plus 18. That's the point here. So if you find the distance between these 2 points by doing, things like 12 minus x squared plus 10 minus the whole monster squared, then you get some quadratic on x here. And if you work out the whole thing, then this is distance equals, right? Then you will get distance squared, that is. You get distance squared equals some huge monster of some sort. It will have x squared term, x term, and pure number term. Then you remember, negative b over 2a. That's the vertex. So that, if you use this a and this a are not to be confused. These are two different things. I'm referring to the coefficient of the polynomial here. If you use that, that will tell you where the minimum x is. So then you will get the answer here. But I think that's more involved. The distance between point and a line is always perpendicular to it. If not, you can just draw anywhere and claim it to be distance. Got to be perpendicular to it. I think using this perpendicular slope is more clever. And this math competition is all about being clever. So let's use this and get the answer.